My name is Kedar Kulkarni. Today's presentation topic is AI-driven DevOps, how LLMs and agents are changing the software delivery. This is my first time speaking at KCD or any Kubernetes events, and so I'm a bit nervous. So please give me some smiles. So I'll have fun while do. So I worked at VMware and Red Hat before I joined Apple as a senior DevOps architect. One of the things that I'm most proud of is during my time at Red Hat, I was able to co-found a project in Ansible space, and it has garnered 1.3 million downloads, and it's still growing. I'm not working on that project anymore, but it's still being used, maintained by the community, and I'm really happy about that achievement. Disclaimer, standard views are my own, not speaking for Apple or anything that they do here. With that, before we understand how LLMs and agents are changing the software delivery, what does software delivery mean to us, right? Traditionally, somebody's writing code, we are building it, we are testing it, deploying it somewhere, and then day two operations where we are monitoring it, observing it, making sure it is running, performant, secure, serving our customers, etc. But in reality, we are far from that, right? We are actually dealing with multi-cloud systems. Just before me, Shravani presented her presentation about how they have private cloud, multiple clusters, probably some public cloud in the mix. So we are dealing with hybrid infrastructure all over. We are dealing with microservices and their dependencies, their intercommunication, and service meshes. We have to also be aware of security and compliance requirements at all times. We also need to plan for incident response. We need to do capacity planning, which is another thing. If you have any on-prem infrastructure or cloud infrastructure, you need to plan for costs. You need to plan for what capacity you're going to serve, what is your users' growth going to look like, etc. So as a person in the DevOps space, and when I say DevOps, I just want to make sure that everybody understands. For me, DevOps is like DevOps, SRE, platform engineer, cloud engineer, CI/CD engineer, release engineer, whatever you call. All of them are same. I think the only field that's mostly well defined in our industry is full stack software engineer. Beyond that, everything is like giant lump of things. Like you have a job, you get a paycheck, you do things. That's it. So that's DevOps for me. And so as a DevOps person, I feel like I need to basically be juggling all of these things to deliver the software, right? And when I'm doing that, one of the favorite terms that I use, toil, comes up a lot. Because when you're in this space, you're toiling away, and the toil can be very costly. It has real cognitive load and then real associated cost with it. I like to break down the toil in 3 different categories. The first one is like, oh, that was too loud. The first one is pattern recognition, second one is context switching, and third is knowledge access. And these are all interrelated. And I like to spell them out because everybody of us is dealing with this toil. Not many of us are speaking, right? This is rarely part of the discussion. When you are solving a problem, your management wants to know that you solved the problem and got it done. What's the cost behind it? This is the toil is the cost. You're trying to constantly scan through logs. Let's say you're trying to solve a problem, and when you're doing that, then you're trying to correlate the logs between different systems. Just in, again, previous presentation, I don't know how many of you are listening, but there are so many tools that Shravani said they use, and every tool has their own language, own types of logging, own metrics, own observability stacks, and you're trying to make sense of all of that, and you're trying to recognize patterns that are most relevant to the problem that you're solving at any given moment. Then you're doing context switching between all of those tools and also trying to find the right Slack threads, right documentation, right person who might be able to help you. And all of these things really also make it feel like we are burnt out all the time. There is pager fatigue. A lot of times I have also observed in my career, you get paged for the P0 or P1 category incidents that are beyond your expertise. I mean, calling a network engineering to fix database error is one of the classic ones. So all of this comes with a real cost, and that is the cost that I hope and I think AI can start helping us solve a little bit. It can make our lives a little bit easier. And in technology, I think the goal of the technology is to reduce friction, and That toil is the friction, and AI is trying to solve that for us. But on this slide, I'm really trying to decode AI for DevOps teams. And I'm not an AI engineer. I'm not a researcher. I don't build models. So I'm trying to make it as simple as it can be. And LLMs and agents are two terms that are used very interchangeably in all conversations all the time. But these are really two different things, and understanding them is a key to understand what you're going to use them for and how you're going to benefit from it. So LLMs is in very simple terms, it is advanced pattern matching. It is like a smart search, like let's say grepping through ton of files and trying to find something, but also once you find it, it's going to summarize that for you and generate a valid answer for you. So it's a little bit like smarter version of grep, if I were to be overly simple about that. And AI agents is where you actually have like tools, you actually have access to different things, different parts of the system to actually take decision, and you have that decision making loop going on. So you observe, you use tools, you act, you observe again to see if the task is actually fulfilled. If not, you keep going on in the loop. So LLMs is like a senior engineer who's out on a vacation. You can call him and he can tell you things, but he cannot access his laptop, so he can't do anything. Agents, on the other hand, is a person who's always available and can do everything that you ask it to do, but you need human oversight because he can make mistakes. So I think with the help of AI, when we are solving the problem with toil, we are solving the problem in DevOps space, we have to recognize that AI can act as a great equalizer for the teams. There are four different personas, or four different kinds of things that AI equalizer can be helpful for. First is if you're a junior engineer, you're just starting out your career. Previously, you relied on onboarding documents, which are mostly outdated by the time you join the company. And then you're trying to figure your way out, and you're constantly trying. You're having that imposter syndrome. You just joined the company, you don't know if you can do this thing, and then you're shy of asking questions. AI can be of your help. Like if the company has a great AI solution that is tapping into all of the internal documentation, you can ask questions to that AI and be able to come up to speed without feeling shy about asking questions to somebody. AI can be that somebody without judging you. The second thing is senior engineers, the person who's at my level or person who's seasoned in their career. We are not always about solving the problem at that point. We are always trying to look behind and look ahead. Like, was this something that happened previously? Is this something that may happen again? You're trying to actually look at the bigger picture. And when you're doing that, AI can act as a thinking partner to quickly help you deduce the knowledge. If you have like tons of notes that you have maintained over the time, your team has maintained over the time, even though it is probably unstructured, maybe it's the Slack conversations, like a lot of war room discussions, whatnot. Whatever that is captured knowledge, AI can actually help you look through it quickly and help you understand the bigger picture that you need to look at as a senior engineer and beyond. I'm a non-native English speaker, and when I started with my tech journey, I did not understand what is a container, what is Kubernetes, what is Helm, what is inference in the world of AI. I did not understand a lot of terms, and I think all of us face that issue at some point, being native or non-native, but non-native English speakers feel that pain a little bit more. And I don't remember of a time when I went to somebody and I asked like, hey, what does that Helm mean exactly, right? Like, what does the logo of the Kubernetes mean? Like, where does it all come from? But now I can ask those stupid questions to my AI, and it can help me understand like what exactly all the technical jargon means. And lastly, we all have different learning styles, right? Some people are visual learners. Some of you like to learn by looking at images and diagrams, architecture diagrams. Some of you really probably want to look at hands-on guides, step-by-step guides and labs to actually see how a thing is working. And some of you want to listen to a lecture. That's why you're here waiting for lunch. So for different learning styles, you can prompt your AI to just, hey, I want to understand what is Carpenter. Can you just give me a step-by-step guide to maybe start a Minikube cluster or Kind cluster and just understand how it will all work? Give me a quick tailor-made guide to try out this technology. And AI can do that. So it is basically trying to bridge the gap between the people who are new to the team, people who are non-native English speakers, people have been here forever and lifelong career had in a specific company. So all of that gap is bridged by this AI, and that's why I call it a great equalizer. Now, from here, we are going to jump into a live demo. And as we were looking on the previous slide, right, we were looking at different personas and how they can benefit from AI. So even in this demo, I'm going to do a persona-aware troubleshooting, and there are 4 personas I've identified: a junior engineer, a senior engineer, a security personnel, and a business personnel. So it is pre-recorded demo, and I'm just going to, hopefully this works. Can everybody see it? Okay. So what we have here on the right-hand side, I have a kube cluster with a broken Nginx deployment, classic. On the left-hand side, I have something called kubectl AI, one of the open source tools that you can also go find out easily on GitHub and play with. And as a junior engineer, if I see this scenario in my cluster, what am I going to do? I'm going to be like, help me understand what's the issue, how I can troubleshoot it. And this kubectl AI, acting as an agent with access to tools to call kubectl, it is telling me that, okay, this is the issue, this is a problem I see in the cluster, and do you want me to fix it? Yes, yes, don't ask me again, or no. And then it's actually trying to tell me, like, this is the exact command, kubectl patch deployment, and run this command and it should fix it. Do you want to run it, or I can run it for you? But now, let's switch that persona. Now, if you're a senior engineer, you're probably going to also want to think about, well, this is broken right now. Was it broken ever before? Is there a pattern that I can find out? I may want to look at the deployment and rollout history, right? So now I'm like, help me analyze history of the deployment to see if there are any patterns, any concerns, right? And kubectl AI or AI would help you do that as well. So as you can see, I'm typing that away, and AI looks at the history of the deployment. It is looking at 3 different revisions, and then it asks me if I want to compare the last 2 revisions. I say yes, and then it is going to tell me exactly what was the difference between those 2 revisions for me, right? And based on that, it can say, it is telling me that, okay, are you ready to fix this deployment? I found this is the issue, the image tag might be wrong or whatnot. And there is a explicit call to exit one, which is going to crash the pod. But now switching gears to another persona. Now, if you're a security engineer, or I feel like security is everybody's responsibility, so even you can wear that hat for a moment and ask that question, like, is there anything malicious, any bad actor pattern that we see in this deployment? So when I do ask that question, so I say, is there anything malicious activity with the pod? And I get an answer that, well, looking at the pod logs, I see there is a exit 1, so it's just an error, there is nothing suspicious. But pay attention to this bottom part here. It says it's unlikely to be malicious, as a malicious actor would typically try to keep a pod running so they can exfiltrate or infiltrate the system, exfiltrate the data or whatnot. So this is definitely not a security problem. So you previously you would ask that to a security engineer or some person on your team who is more into security than you are. But now you can also use AI to supercharge your capabilities and at least do like level 1 of triage, like what's going on and is it related to security. But now if I'm a business person and I just got a small report based on what's going on and there is an outage and whatnot, I don't want to know all of these details. But when I look at the report, I would probably want to go back to the engineer who submitted the report or status update at that moment during the crisis. Hey, how much time is it going to take to fix? Because I need to communicate that out to my customers, to my business. And when I'm doing that, I would typically go back and bug the engineer who wrote the report. But with AI, I can just ask AI, look at the report and tell me how long will it take to fix. So now that's exactly what I'm asking here. And when I do ask that, AI says typically it should take under 2 minutes. So I'm going to go ahead and tell the business 30 minutes, we should be good, right? And then finally it's asking me if I'm ready to patch this now, and I say yes, and then by the end of the demo, it's going to patch that, and then deployments are going to be running and everything. But I'm skipping through it. This is all available on YouTube and will be shared later with all of you. So this was our first demo where we are just using one single tool from open source world with my personal Gemini token, but you could use any token from any AI application you want, and it can help you troubleshoot things that are going on in your cluster. This is a specialized tool. This is kind of an agent, right? But then, let's see, next slide. In my second demo, I want to pair that kubectl AI with another open source tool called Kubernetes GPT or Kubernetes GPT, right? This presentation was actually previously presented at All Things Open, which is another biggest open source conference in the US. You may have heard of. If not, please check it out. And in the spirit of open source and my open source background with Red Hat, I tried to keep this open so that you can watch this demo and maybe in an hour after your lunch, you can actually try to download these tools and play with them yourself and understand how they work, right? So this is a demo of how we can do a self-healing system within your Kubernetes with the help of AI. And the two things that I'm using, as I said, is Kubernetes GPT and kubectl AI. But Kubernetes GPT comes with two flavors. One is more interactive, like kubectl AI, but the other one comes as an operator that runs in your cluster, right? So in there, okay. So what we have here is on the top, I have kubectl AI again. I'm going to ask it to simulate breaking the deployment. On the bottom left, you're going to start seeing some pods that go from healthy state to broken state. And on the right-hand side corner here, you're going to see the outcomes. Results is the object that Kubernetes GPT creates every time it finds an issue with your cluster. And that results object is going to have information about what it found, what was the issue, and what is the potential solution. But it does not actually apply the solution. At least at the time when I recorded this demo, it did not have those capabilities. So if I were to build a self-healing Kubernetes agent, how would I do that in this scenario, right? So first I am asking it to update the Nginx deployment and ask it to break it deliberately. So now it's gonna try to pull a new image, which is image ATO 2025. And then the happy, healthy deployment goes into error, right? Now you can see immediately the operator that's watching my cluster created that results object. And in that object, if I describe that object, it's going to actually show me those things, right? It's going to show me what's the error, what's the potential solution, etc. So as you can see, it has a solution mentioned here, verify the image exists, and check if the image is in Docker Hub and whatnot. But now, to tie them all together, tie these two tools all together, like kubectl AI had capabilities to interact with my cluster and get things done, versus Kubernetes GPT is just watching things happen and telling me what's happening. So to fix an error that Kubernetes GPT found, I wrote a demonstration script here that basically calls them in a loop. So kubectl AI is going to look at all the results objects that are getting generated over time and keep watching them. And every time it finds a results object, it's going to look what it says, and it's going to see if it can actually apply that solution to your cluster to break, to fix whatever the problem is with your cluster. And it works well with simple problems for sure. But for something more complex, you may not want to have that. But let's see how it works here in this case. So I'm running that custom script, and script is just a way I'm demonstrating it. There might be better ways to put them all together and run it as a single large operator in your cluster to fix the problems. But now you can see that it went from completed, pending, container creating, and running. So it was able to look at the problem and come up with the solution and apply that solution for me. So that is the power of like creating something like self-healing Kubernetes AI. Let's see what else is remaining here. Yeah, so it's just showing the container is running, and if I look for results object, there is no more results object because it has been consumed. So what we learned from these two demos is like we can use AI, and AI gave us the superpower to look at large number of things or even watch things constantly. Maybe you can also ask it to ingest logs instead of looking at the cluster. But no matter what you're doing, it can actually help you speed up the things. And where I would use something like this, right? I would definitely not want to use this in production environments, for sure. And we'll talk more about that as to why. But let's see, there is another thing, right? Intelligent CI/CD. So what we previously saw is how things will work in the kube context, but we all have CI/CD pipelines that we are dealing with all the time. And if I were to adopt AI, I see it in the spectrum, right? 1, 2, and 3. The first is advisory, second is semi-autonomous, and third is autonomous. What we saw in the previous demo was fully autonomous. Would I go there? Probably not yet. So that's the rule of thumb here is like column 1, like just doing RCA for CI failures, risk assessment for like Terraform plan output, which is like thousands of lines. Those are kind of things where you can actually use AI today, and or looking for PR risk scoring, creating release notes, classification of flaky tests and whatnot. All of those are good use cases to apply starting today. But something more advanced would be like, for column 2, it would be like something you would pilot. You'll make sure that there are guardrails in place and there is human in the loop always. And 3 is like fully autonomous, and I don't think we are there yet. So don't deploy that anywhere unless it's just your toy cluster, like what I was doing in my demo. And how would it look in practice, right? The RCA failures is one of my favorite use case for using LLMs anywhere in the CI pipelines, because a lot of times the CI pipelines generate also thousands of lines of logs, and finding that needle in the haystack, why is this pipeline suddenly broken out of nowhere today, is the issue that I think we all deal with constantly, especially when a project is in active development. There's a lot of things can go wrong, right? The software engineers just write some code that has bad import that does not exist in the environment, and it's going to fail. But who gets the ticket? Guess, DevOps. Fix the pipeline. So DevOps need to be able to quickly look at the pipeline and tell that, oh, you imported something, but you did not install that in pip requirements, so please do that. And it speeds that up. And later, for Terraform plan also, I feel like every time I look at Terraform plan output, I'm overwhelmed. And I think that's a constant state of mind for me. I don't know how many of you agree. But the Terraform plan output for any kind of Terraform apply is like hundreds, if not thousands of lines all the time. Doing something like this with LLM, using LLM for coming up with quick judgment, like what it is doing is correct or not, and then being that person in the loop to just read that summary of what it is planning to do and hit yes or no. Those are some practical ways we can use LLMs today the way they are, and it's sort of a safe way to apply LLMs. Ultimately, what I want to convey from this presentation in the DevOps space or any other space is like AI knowledge plus human experience is those infinite possibilities. This is the one thing I would expect all of us to understand and take home with us today if you just wanted to remember one thing from this presentation. Because right now, the state of AI is very much in flux. It's changing every day, and people think AI can go to Mars tomorrow, but it's not there. And without human experience, we can't do that. Like people who went through Apollo missions or the Artemis mission, they have the experience that they've got, and I don't think every single minute detail of that experience is codified somewhere, right? That's why that human experience is needed. You cannot just say now, hey, NASA, remove all the people, just put an AI agent, create a rocket, and send me to Mars. That's just not going to work. So we need to really understand that we play a critical part in this journey of evolving AI and evolving the tech industry. And as I promised earlier, why we can't run these things in the production just yet, in my personal humble opinion. Different teams from different companies with different customer sizes and whatnot, everybody will have their different AI journey and different applications of AI. And you are the best person to judge that. That's why you are in the equation of AI plus human is infinite possibilities. Without your judgment, you cannot apply AI just randomly. So start small, measure impact of what you're doing, iterate slowly, measure always the ethics, weigh the risks versus the benefits, and ethics and inclusivity should be built in from the get-go. With that, thank you so much for listening.